The shipping container one it's an ongoing joke in the industry because it's like modular construction, which we've talked about before, you and I. It's the idea that won't die. People are so enthralled with shipping containers, and it's like telling them their baby is ugly to present challenges to the idea. And I think it's what people do is they get attached to an idea or in this case of shipping containers, I think it's not just an idea, but an aesthetic. And then they work backwards from there in trying to justify it, as opposed to having a problem and letting a solution to that problem emerge more organically. And I really think this is the shipping containers and some forms of modular attachment to modular construction work in that way. It's people like the idea of these building blocks and standardization and technology, and they've got a point to a lot of this stuff, but they want to then reverse engineer and make the problem fit the solution that they've already arrived at, rather than the other way around. And shipping containers is just such a great example of that, where particularly the aesthetic part emerges, where you can actually you can make shipping container construction work, and the easiest way to make it work is to insulate on the exterior. You mentioned dew point, and you mentioned I prefer to teach in terms of condensation control. And when you've got a metal building in particular, the easiest way to, and I mean, any building really, the easiest way to control condensation is to insulate on the exterior of the structure and do water management on the exterior of the structure as well. And so you could do that with shipping containers, but the second you do that, what happens to your shipping container aesthetic? Well, it no longer looks like a shipping container, and people are like, well, I don't want to do that. So they want to use spray foam on the interior. And you can do that too, but there are some real challenges with that as well. And you'll get differential. You're going to have to contend with differential expansion from heat. A metal building, as you might imagine, can get extremely hot. You've done all this stuff before, and anybody listening to this who hasn't listened to your series of videos on shipping containers would be entertained and informed by doing so. But yeah, it's you doing spray foam on the inside doesn't solve every problem. Although you could make that work too. It's just very difficult. I actually got a call, I think about 2 or 3 weeks ago, from someone who had done that, who had made a shipping container house, spray foam on the interior. And the house in question was in Texas, and they were getting leaks at their windows because the windows were warping because it was exceeding the in-service temperature limit of the windows. So the windows were warping, which pulled the sealants between the sealant and the shipping container, and they were leaking even. And then now they were not just warping, but now the windows are leaking. You can also sometimes, if you this is true with other metal buildings that you spray foam up against as well. But if you spray the foam right up against it, the differential thermal expansion can make these very loud popping sounds as the spray foam debonds from the metal. Wow. And so if I were going to do that, if I were really intent on, or if I had a free shipping container and I had the shipping container at location and a need to provide housing, I'd put a drainage mat down and essentially drain the shipping container at the base somehow, and then spray the foam against the drainage mat. Anyway, there's all kinds of ways that you could make this stuff work, but at a certain point,
is it worth it?
I know, right? I mean, it's also like, what problem are you solving?
Exactly.
We can make homes, a simple home out of dimensional lumber, pretty quickly and pretty inexpensively if we want to. So what's the problem we're really trying to solve, and is the solution, does it fit the problem that we have?